So Erin and Krista were working on cubing binomials for math homework. Erin believed they could save time with a shortcut. She wrote down the rule below for Krista to follow. So does Erin's shortcut always work? So there might be some convenient numbers for A and B where it would work, but always works means we should be able to prove it. And proving it, not that it says the word proof or verify, but I think hopefully on the onset you know, just looking at it, this should be a big no-no. We don't distribute exponents to binomials. But to prove it, we would simplify the left as a separate question, simplify the right as a separate question, and see if they're equal. Now the right-hand side is definitely already simplified. The left-hand side needs some work. A plus B times itself 3 times. And then we would start with the first product. So this product would become A squared plus AB plus another AB plus B squared, which would combine to 2 ABs there in the middle. Okay, and you still have the A plus B, so make sure you're carrying that down each step, because cleanliness of a proof and exactness of a proof is part of the issue. So there's the first 2 multiplied together. Now we need to multiply that product by the third. So we're going to do a distribution of the A squared, which will be A cubed plus A squared B. A distribution of the 2AB to both terms, which will be plus 2A squared B plus 2AB squared. And then on the third, now even though I'm doing B squared times A, all my A's are preceding the B, so I'm going to do the A first and the B squared second, and then plus B cubed. So when I go to combine like terms, I have 1A squared B and 2A squared B's, which makes 3A squared B's. I have 2 AB squareds plus another AB squared, so 2 plus 1 of those is 3 of those. That's with a regular A and the B being squared, and then plus a B cubed. And does that equal, and this would just come down, A cubed plus B cubed? Absolutely not. Again, if your numbers A and B were zeros, A is 0 and B was 0, then it would work. But the answer, make sure you answer the question. Our justification is the proof. Does the shortcut always work? No. In fact, it almost never will work. Okay, we have probability here. The probability that a resident of a housing community opposes spending money for community improvement on plumbing, opposes plumbing, is 0.8. The probability that a resident favors spending money on improving walkways. Okay. So they're giving us probability of opposing plumbing equals 0.8. Probability favors walkways given that they oppose plumbing is 0.85. Determine the probability that a randomly selected resident opposes, so we're looking for the probability opposes plumbing and favors spending on walkways, and favors walkways. Okay, so that's our question mark. So I am thinking here of a Venn diagram. Our 2 circles are opposing plumbing, and our other one is favoring walkways. Okay, and we have an X number Those are the people who oppose plumbing and don't favor walkways. Here's the people that do both. This is essentially what they're asking me for, who opposes plumbing and favors walkways. And then just favoring walkways, and then we actually have some, but like the number that would be out here. So the probability of opposing plumbing is 0.8. So x plus y is definitely got to add up to 0.8. Now, the total probability, like if it's percentages, the total percentage has to add up to 100%. If it's probability, the total probability has to add up to 1. So if x plus y adds up to 0.8, then w plus z has to add up to 0.2. Again, I don't know if we'll need that, but just wrapping your head around that. If 80% of the people fall in here, then the rest of the 20% have to be between z and w. Now this one is tricky. You're favoring a walkway given that you oppose plumbing. So what we know about given probability, and they're giving us the answer, but the denominator comes from those who oppose plumbing, because that's your given. And the numerator comes from both. So since we know that the opposing plumbing is 0.8, we can solve for both, since the whole probability needs to equal 0.85. So I'll just transfer that 0.85 over here. So if I solve for x, I'm just taking 0.85 and multiplying both sides by 0.8. 0.85 times 0.8 is x equals 0.68. And that's your both category. So I shouldn't have called it x, I should have called it y, just because that's what I used in my Venn diagram. And to be truthful, I don't really need to even finish out the Venn diagram. The probability of both is 0.68. And that's what they want, 0.68. If they asked anything else, I could finish my Venn diagram, I believe. So if y is 0.68, and x plus y needed to be 0.8, 0.8 minus the 0.68 that's already accounted for would be 0.12. And, you know, I would have a tough time figuring out how that additional 20% is split. They didn't give me enough information for that, but, you know, that's as much as we can figure out given what we have been told. And it was, once you wrap your head around the given probability and what that actually, how you would actually calculate that, they gave you the answer, and then you knew the denominator, so you could solve for the both, which was the numerator. Here we have Rowan training to run a race. He runs 15 miles in the first week, so I'm thinking A sub 1 is 15. I'm immediately thinking sequence and series chapter. And each week following, he runs 3% more, okay? So when you increase by a percentage, you have to decide arithmetic or geometric. That's a geometric. And the R value is 1.03 because you want this number to increase. So you have to be multiplying by something greater than 1, and it's 1.03. Using a geometric series formula, so they're pretty spot on with just flat out telling you what that is. So if you go to your reference sheet, steal that formula. S sub n equals A sub 1 minus A sub 1 times R to the n power, all over 1 minus R. Let me just double check that to make sure I transpose that right. A sub 1 minus A sub 1 R to the n over 1 minus R. So, okay. So there it is. Find the total. There was another indication. They didn't even need to tell you geometric series, but they did. That was nice of them. Find the total number of miles he runs over the first 10 weeks. So n is 10. So we're looking for S sub 10. Our first term is 15 minus 15. Our R is 1.03. The 10 weeks. And then 1 minus 1.03. So let's just make sure we can plug this in properly. So if you have alpha y equals, you can do that. I don't on this calculator, so my entire numerator needs to be in parentheses. 15 minus 15 parentheses 1.03, close parentheses to the 10th power. Close my numerator. Divided by a set of parentheses around my denominator, 1 minus 1.03, close. And so I get that number, 171-ish, 172-ish miles total. And anytime you get a weird decimal, you want to double check. Did it tell you to round? Yes, nearest thousandths. So tenths, hundredths, thousandths. And that 8 is followed by a 1, so that's going to stay in 8. 171.958. And give it a unit. How many miles? 171-ish miles. So pretty straightforward, just using the series formula. The only thing I can think of is that people would use .03. But truthfully, if the multiplier was .03, then you'd have in the second week, 15 times .03, you'd have them only running 0.45 miles, which is clearly not right. They're not going to run that much less in the second week. 15 times 1.03, on the other hand, has them running 15.45 miles in week 2. So they're training for a race, so they're going to be running more and more every week. Here we have a trig function that's giving the average monthly high temperature in Buffalo in Fahrenheit, where T is the month number. So January is 1, February is 2, okay? And we want, to the nearest tenth, the average monthly rate of change. Average monthly rate of temperature change. Screams slope. So we want the slope between August, which is month 8, and November, which is month 11. So we need to find the average temperature in August, the average temperature in November, and then do the slope formula. So trig equations like this are always in radians. So first things first, make sure you're in radians. And then we can just type it in. Let's see, we can type in the function if we want. So we only have to do it once. Okay, and then we can do second trace and look for a value on that function. Now I'm not seeing much because I'm only looking from -10 to +10 as my temperature, and I don't think the average temperature is ever that low. So if I wanted to actually see something, I could let my temperatures go from like 0 to 100, and my months go from 0 to 12. So I see a full year from 0 to 12, and then how the temperature each month is oscillating. So second trace value in the 8th month, 78.902618. 78.902618. And then second trace value 11. So in the 11th month, I could grab these numbers from the table if I wanted as well. 48.732201. So that's what I got. So the average rate of change is Y2 minus Y1 over X2 minus X1. So again, on my numerator, keep parentheses around that difference, 48.732201 minus 78.902618. That's going to give me negative 30.17417. So that shows you that the temperature is dropping. That's in degrees, right? These are your temperatures, so degrees. So it's dropping 30 degrees over a span of 3 months. And rate of change says we actually need to do that division. So we're going to divide it by 3, and we'll have our average rate of change. -10 point, nearest tenth, 1 degrees per month. The units sort of take care of themselves. So when you explain its meaning, you can say from August to November, the temperature, the average monthly temperature is dropping by 10.1 degrees per month. you don't want to say dropping by negative. So your dropping is kind of addressing the negative sign. Okay, 31 looks like a little bit more like trig. Okay, point M, t comma 4/7 is located in the second quadrant, so here, over here somewhere, on the unit circle. So we're going left t units and up 4/7. So that's 4/7, and this is t, and it's the unit circle, so we all know that's 1. Determine the exact value of t. Well, t is definitely a negative number. Let's start with that. And then the other part can just come from the Pythagorean theorem. T squared plus 4/7 squared equals 1 squared. So this is t squared plus 16/49 equals 1. And then we can subtract 16/49 from both sides. So that would be 1 minus your 16/49. So you'd get t squared equals, if I want to math frac that, it will be a fraction, 33/49. And they say exact value, which means you don't want to grab that decimal. That would give you not an exact, that's rounded. Exact is a fraction, so if we square root both sides, t equals plus or minus the square root of 33 on top, and the square root of 49, which is 7, on the bottom. And we've already decided, is it plus or minus? Well, based on the location in the second quadrant, it has to be a negative. So t equals negative root 33/7. So, as I've always said with trig and the unit circle and all of these triangle pictures, draw them. It makes it so much easier. Here they want us to graph a function. It amazes me how poorly we do on these. You have a calculator. You have tables on your calculators. Type this in. Now, if you don't have the log-based function, you obviously have to know the change of base formula. So you have to do the log of this divided by the log of 2. So I will do it with that in mind. So the log of x minus 3 divided by the log of 2, and then plus 1 at the end. So if I go back to Zoom 6, just to look at my standard negative 10 to 10 window, so there it is. It clearly stops, well, it looks like it stops. We should know that log parent graphs actually have an asymptote right here. So there is an asymptote somewhere here. It's obviously been shifted to the right a bit. Based on your parent graphs, you should know it's been shifted to the right 3 units. So you should have an asymptote at 1, 2, 3. Do not let your graph cross that line, and then for the rest of it, just take points. So you have all these errors at negative numbers all the way up until even 3, where the asymptote is. But your first point is 4, 1. Your second point is 5, 2. And it's already scaled for you, so that's nice. Stay away from the decimals. Look for the nice ones. 7, 3. And 11, 4. Okay, so that's enough. And this, paired with what you should know about a log parent graph and the location of an asymptote, you don't want to stop that right there. You want to make sure it goes down infinitely with an arrow and never crosses that vertical asymptote that's at 3. How do I know that my vertical asymptote's at 3? Because that's where the graph started to not exist with values. So we can get infinitely close to 3, but once we hit 3, there's an error. And there's your function. Okay, systems in 3 variables. It's been a while for this one. So what I say for this is always elimination 3 times. However, ABC equals number, ABC equals number. This is pretty nasty because it's not in the right order. We want to get it in the same format, the A first, the B second, the C third. So I'm going to change this. I'm going to actually subtract the A over, so it'll be negative A plus 6B plus 2C equals 14, and then I'm going to forget about that one. I just rearranged it. So now, as far as the elimination, if you look at your A's, they all have a 1 in front of them. The B's, 2, 4, and 6, not terrible, and the C's, 2, 1, and 6. Nothing's terrible, but this one's already set up for you. They're all 1s. 1, 1, negative 1. So if they're both the same sign, 1 and 1, we subtract. So 1a minus 1a is gone. I'm going to put little subtraction signs in all these. 4b minus 2b is 2b. 6c minus 1c is 5c. 23 minus 2 is 21. So we eliminated a once. We have to eliminate a second time. These are opposite signs, so we're going to add. So 1a plus negative 1a gone. 2b plus 6b is 8b. 1c plus 2c is 3c. And 2 plus 14 is 16. So I eliminated A. So now I just have B's and C's. So my third round of elimination comes from deciding, should I get rid of the B's or the C's? So unlike the A's that were already all the same number, they're not here. We need to either get the B's to be the same coefficient or the C's. Now I'm going to say that the B's are easier because 8 would be the least common multiple and one of them already is an 8. So this one just needs to be multiplied by 4. So that's going to make it 8b plus 20c equals 84, and then this one I'm not touching. And again, same sign, subtract, subtract, subtract. So 8 minus 8, gone. 20 minus 3, 17. 84 minus 16, 68. Divide both sides by 17. C equals 4. Got nervous that wasn't going to be a whole number, in which case, yes, I would have been suspicious. Okay, so now that we know C is 4, we can backtrack. Let's go back here and do 8b plus 3 times 4 equals 16. Subtract this 12 over. 8b is going to equal 4. Divide by 8, and b equals 4 divided by 8 is a half. Don't tell me that's 2. So not a whole number, but at least it's a nice fraction. And then back to one of your originals. I'll go back to the very top original. So we have an a plus a 4 times a b plus a 6 times a c, which I got my b and c values already. And so this is a 2. I'm going to subtract 2 over. This is a 24. I'm going to subtract 24 over, and I'm going to get a equals negative 3. And there we are, algebraically for a, b, and c. Done. We're getting there. All right, so given a polynomial function and a linear function, determine the ratio, so dividing one by the other with a quotient, and this is just, without saying it, long division. So we have x to the 4th plus 2x cubed. What you have to remember with long division is if they skip a term, so the 4th term, the 3rd term, they skip the square term. So we're going to put 0x squared in there, though, just so it stays lined up, and we're dividing by x plus 2. Okay, and you begin with the leading term. X times what gives me x to the 4th? And that answer is x cubed. You then multiply that x cubed by the entire binomial, so, and line it up. So x to the cube times x to the 4th, x cubed times 2, 2x cubed. And then you do subtraction here, individually. This minus this, gone. This minus this, gone. And then you have no x squareds either, so normally you'd have something left and you'd bring something down and you would repeat the process. But since these are all zeros and zeros, really the next thing we're bringing down is a 4x, and you kind of always want 2 terms. So x times what gives you 4x? Well, 4. So the 4 times the x plus 2 gives you 4x plus 8. Subtraction, subtraction. So 4x minus 4x is gone. Negative 10 minus 8 is negative 18, and that's your remainder, because you cannot keep going. So in this form, your q of x is x cubed plus 4, and your remainder is negative 18 over your divisor, x plus 2. So is b of x a factor? No. Very simple. Keep it simple. Because it has a remainder. Only if the remainder is 0 was it a perfect factor.